The first case we'll take a look at is when we have factors of 1 and 36. Factors meaning two values that can multiply together to get us this fixed area of 36 meters squared. So we're going to have a width of 1 and a length of 36. Notice that 1 times 36 gives us our area of 36 meters squared. What we're going to have a look at is what would be the perimeter of the rectangle when we have a width of 1 and a length of 36. So here's an illustration for the first possible greenhouse, again when we had a width of 1 meter and a length of 36 meters. Our perimeter formula is 2 times the length plus the width, so we'll sub in the length of 36, the width of 1, add those two together to give you 37 inside the brackets, and multiply that value by 2. Which gives you 74 meters. And we can update our table having the perimeter of 74 meters when we have a width of 1 and a length of 36. And we can move on to take a look at our next two values. So we have 2 and 18. 2 times 18 also gives us 36. So we'll look at a width of 2 and a length of 18. And we'll take a look at what perimeter would result with a width of 2 meters and a length of 18 meters. Here's our illustration when we have a width of 2 meters and a length of 18 meters for the greenhouse, and it gives us an area of 36 meters squared. Looking at the perimeter, here's our formula, 2 times the length plus the width. We'll substitute in our value of the length of 18 meters and our width of 2 meters. Add those two values inside the brackets together to give you 20. Multiply by 2, and that'll give you a perimeter of 40 meters. Again, we'll update our table, having a perimeter of 40 meters when our width is 2 and our length is 18. And we'll take a look at our next possibility. Let's have a look at 3 and 12. 3 times 12 gives us 36, so we'll use a width of 3 meters and a length of 12 meters. And again, let's calculate the perimeter when we have a width of 3 and a length of 12 meters. Here's our illustration when we have a width of 3 meters and a length of 12 meters. And we'll calculate the perimeter for this rectangle. So we've got 2 times the length plus the width as our formula. We'll substitute in our length of 12 and our width of 3. Add those two numbers together to give you 15 inside the brackets. Multiply by that 2 outside, which should give you 30 meters. So we've updated the table with a perimeter of 30 meters when we have a width of 3 and a length of 12. Next two that we're going to consider are 4 and 9. 4 times 9 gives us 36. We'll use a width of 4 and a length of 9, and let's calculate the perimeter for this object. So here's the illustration that shows a width of 4 meters and a length of 9 meters. Again, we'll use the perimeter formula, 2 times the length plus the width. Substitute in 9 for the length, 4 for the width. Add those two values together inside the brackets, giving you 13. And we need to multiply by 2 to give us a perimeter of 26 meters. So you can see that we've updated the table with 26 meters being the perimeter when you have a width of 4 meters and a length of 9 meters for the greenhouse. And the next ones we'll take a look at are the values 5 and 7.2. 5 times 7.2 will give you 36 meters squared. So we'll try a width of 5 and a length of 7.2 meters, and we'll be able to calculate the perimeter for this rectangle. So we have a width of 5 meters and a length of 7.2 meters, giving us a total area here of 36 meters squared. Let's find out the perimeter in this case. So we've got our formula, 2 times the length plus the width. We'll substitute in 7.2 for the length, 5 for the width. Add those two values together inside the brackets to give you 12.2. And multiply by 2, giving you 24.4 meters in this situation. So we've updated the table with 24.4 meters being the perimeter when we have a width of 5 meters and a length of 7.2 meters. Our last situation we're going to take a look at is when we have 6 being the width and 6 also being the length. Remember, 6 times 6 gives us 36, and we'll be able to calculate the perimeter for this rectangle. Now you can see when we have a rectangle that has a width of 6 and a length of 6, we actually have a square. So this square has an area of 36 meters squared. And let's figure out what the perimeter is going to be when we have a 6 by 6 square. So we'll substitute in 6 for the length, 6 for the width, and add those two numbers together, giving you 12. And we'll multiply by 2 on the outside, giving you 24 meters. So when we have a rectangle, or in this case a square, that's 6 by 6, the perimeter is going to be 24 meters. So let's check your answers. Remember that our area was fixed as 36 meters squared all the way down, and we had various widths and lengths that we tried, giving us different perimeters for this greenhouse. Now the goal of this activity is to try and find out which width and length, gave us the smallest perimeter of the greenhouse. So this table illustrates the possible widths of the greenhouse, knowing that we have a fixed area of 36 meters squared and the resulting perimeters for each of those cases. What we're going to do with these values is graph them with the width and perimeter, and we'll take a look at the graph to see if it can show us which width will give us the smallest perimeter visually on the graph. So here's our data over on the left hand side. Again, our widths and the resulting perimeter. And we can plot the perimeter on this axis and the width along this axis.